we say AQI, what are the ingredients for AQI? What are the factors that go into it? And there's several factors that go into air quality index. One of them is something called PM2.5. PM is just particulate matter in the air. We can think of it as dust, but 2.5 is its size, and it's quite small. In fact, you can't see PM2.5. It's so small you can't see it. So when you see these dark hazes, you're not actually seeing this very fine particulate. There's PM10, which is just a little bit bigger. There's ozone next near the ground. Ozone is a very harmful gas that's produced from combustion products. And then there's two other combustion products, nitrous oxide and sulfur oxide. But really, when you make those maps of AQI, this color maps, it's almost all driven by this number because it tends to have the highest impact on that calculation. Occasionally, ozone will become a factor. I know even in my own city, ozone in the middle of summer becomes a little bit of a factor, but it's largely driven by this. So how small are these particles? Well, if you think of a human hair, this is the diameter of your hair. This is PM10 in blue. PM2.5 is this tiny bit. The challenge with PM2.5, I'll be talking about a little bit more in the afternoon, is that material is so small it goes very, very far into your lungs, and it does not come out very quickly. So it stays there and causes disease in the deep lungs. So what is that PM2.5? It's actually not what you normally see. I flew in yesterday morning in cataclysmic dust storm into Karachi. I didn't think our plane was going to successfully land, frankly. We did. But when the minute I got out of the plane, there's sand blowing at me. Well, although it probably wasn't good for breathing that stuff is so coarse in that sand that it probably all just came into the upper airways, and I probably coughed it out immediately. So it doesn't actually cause much of an impact, largely because I don't have asthma problems or anything like that. If you did, it could cause an impact. But things like that don't actually always cause a long-term impact. And a lot of other things like pollen and mold are a little bit bigger. So PM2.5, the reason why it's really distinct is it probably didn't really exist before human beings were around. Which is kind of an interesting concept. We're producing this issue. It's largely from combustion. It's of three kinds, but they all related in a number of chemistries that make them problematic. But they can also go pretty far away. There's local sources, and there's combustion of coal, oil, vehicles that come out of vehicles. They come straight out of the tailpipe of these things, and they react with the chemistry of the air and make these very, very fine particulates, which are very reactive in the lungs. And then there's secondary sources where there's a combination to make some chemicals that are also bad for the lungs. One of the difficult things at PM2.5 is it blows a long way. So if, for example, there's a region in Canada, the country of Canada, just north of the United States, where they have no industry whatsoever, but they have pretty bad air quality for PM2.5. It's because a lot of the bad PM2.5 produced in the United States blows onto them. It crosses boundaries, and this is why one of the reasons why the United States State Department has its bureau on this transboundary pollutants, because like water, air just flows, right? It knows no boundaries, it knows no national borders. So it can be a real problem, and you have to make agreements to improve air sometimes. So as I mentioned, when you breathe in the coarse material, so anything coarser than 2.5, it gets into your airways and into what's called the bronchia. So if you're familiar with asthma, there's breathing problems. A number of people have, actually, it's something like 20% of all people now have asthma. It's largely because we're a little susceptible to it, plus we we've grown asthma ourselves as an autoimmune disease in a sense, so we've become more sensitive to it. Asthma is largely caused by the coarse material in the bronchia, which restricts it. But the finer material, it gets down to the alveolar network down here of the lungs. When it's down here, it doesn't come out very easily. Here it comes out within 1 hour. We cough it. Here it could stay down days, years, or decades, depending on the shape of that particulate. And when it stays there, it just keeps reacting in your lungs and causes these deep airway problems, which are almost impossible to treat effectively. Asthma is pretty easy to treat effectively if you have the proper amounts of medications around. These deep lung issues are not easy to treat. And we're finding as we get more and more research done, is not only does it cause these acute problems, which we've been aware of for a while, it causes bad air, particulates causes asthma attacks, it actually causes heart attacks as well. But there's actually some of these long-term impacts that public health experts are realizing are a real concern. And they include heart disease, lung disease, and so forth. We found that some particular groups are highly at risk. I just mentioned earlier that I don't have any history of asthma, nor do I have any, I don't enjoy breathing bad air, but it doesn't significantly impact me. But there are some populations that really are, and those are those that with already with some diseases of the heart or the lung. So think about this. What's the age population of people who already have some problems with heart or lungs? Older people, right? And so they're a very susceptible population. And children. The issue with the children is that they are very active, right? So they breathe a lot of air. Children breathe a lot more air than any of us do here in the room. They breathe a lot, so they take in a lot more of the particulates. And also, their bodies are still developing. And finally, pregnant women, and this is probably the most terrifying recent result that I've seen in the sciences in the last 2 years. They have found that pregnant women who are in areas with a lot of this fine particulate matter, PM2.5, they found that the PM2.5 from the mom, from breathing it in and incorporating it into the bloodstream, goes into the fetus. So you have newborn babies who've already been exposed to environmental contaminant before they even had a chance to take their first breath. And this is particularly important because these fine particulates can also end up residing in the brain. And the research here is still not very clear, but some of the brain diseases, I don't know if you're familiar with the terms Parkinson's and other diseases, there is very likely to be a relationship between metal in uptake from bad air and Parkinson's disease. As we say, the jury's still out on that. I always wait until the science is sound